Okay, so this one's the last video for chapter 7. So this is 7.7, long division of polynomials. We got a couple of different problem styles in here to look at. We're going to have this kind where it's a bunch of math being added or subtracted over a mononomial, so no addition subtraction happening in the denominator. And then we'll see some more coming up that have addition or subtraction, so we got to distinguish between those two problems. So this right here is actually came at the end of chapter 4, I think, of Math 94. These are the ones where you can just split it up. And it's that this negative 5x squared belongs to every one of the terms. So we can write it out like that, and then we can just cancel each of these. So this is going to go negative 2, 10 and divide by 5. We have 4x's up, 2 down, so I'll leave an x squared. And then positive negatives, that's negative. 5 goes into 15 3 times. 3 up, 2 down, so it's an x. And then double negative here, so that'll be positive. X squareds cancel, and 20 divided by 5 will make a 4. So that one's pretty friendly. Those ones we like. And then there are these ones. So these are the kind where there is addition and subtraction, so we can't just kind of split this up and cancel. So we have to have a different way. When you're going through the homework, you'll see the first few questions are like that, and then after that it'll switch to some that say like divide by factoring or something, but they'll have factor in the directions. And so this is basically just a 7.1 problem where I can factor the numerator. We're doing what multiplies to 50 and adds to be 15, so that'd be 5 and 10. And that's over x plus 5. And just cancel those, and so the result's x plus 10. So that's nice when it factors, but they don't always factor, and so then that's where we're going to have this other method that we're going to see. So some of the directions will say factor, and that means you can just do this. Then it will say, after that, divide using long division, and then that's what this is. So long division is exactly what it sounds like. If I had, 10 divided by 2, I'd write that 2 goes into 10. So that's exactly what we're going to do here. X plus 5 goes into x squared plus 15x plus 50. And if we think of long division, I'm going to just make up one right here real quick. If we think about kind of the steps, we go 3 goes into 17 how many times? And that would be 5. And then remember how we go 5 times 3, 15, and they would subtract and get a 2. I'm going to change that to an 8 so that I have a remainder. So we get 2, and then I can bring down the 8. So then 3 goes into 28, 9 times. That makes 27. And I get a 1. So that's kind of your basic algorithm for long division. Is we go 3 goes in, and then figure out what the number is. 5, 5 here, 5 times 3, 15, subtract, bring down the next thing, and then just do it again and again until we run out. 59, and sometimes we wrote that remainder 1. We can also write it as 59 and 1/3, so 1 over the divisor, the remainder over the divisor, and that's what we're going to do with these. So the steps for this are the same as the steps for that. This is just much less pleasant and much easier to lose track of the signs on. 3 goes into 17, that's a fairly easy thing to think about. X plus 5 goes into this stuff is a little bit harder to think about. So a good way to say it to yourself is, what do I multiply this x by to make it exactly whatever's up front? Because when we subtract, we're going to want this thing to cancel. So it has to be the same thing. So what do we multiply x by to make it x squared? Would be x. And here, if you notice, when I went 3 into 17, I didn't put the 5 above the 1, I put it above the 17 over the 7, because that's what we're dividing into. So I do the same thing here. So what do I multiply x by to get x squared? X, and it goes over the x, the linear term. And then here we went 5 times 3 is 15, so here we have to go x times x plus 5. So x times x makes x squared. X times 5 makes 5x. And we subtract, we still subtract. So x squared minus x squared is gone. That's what we want to happen. And then 15 minus 5 would be 10x. We brought down the 8, we bring down the 50. And then we do what do we multiply x by to make it 10x? Well, 10. So 10 times x is 10x, and 10 times 5 is 50. And you gotta get the parentheses around. I didn't mention that up here. We need the parentheses to make sure that we're subtracting the 5. So if we just look at the signs, it's easy to accidentally get a 20 here, and that's kind of where these things go wrong. You just have to remember you're subtracting. So 15 minus 5 for 10. So here 10 minus 10 is gone, 50 minus 50 is gone, remainder 0. That makes sense because it factored, it went in evenly, canceled, so we got the exact same x plus 10 in both places. So if you can factor, oh my gosh, is that easier? But sometimes you can't factor these, sometimes it's not factorable, and then this is what we got. There's actually one more method for doing these, and it's called synthetic division, and it's really, really super easy. It looks confusing when you first see it, and then when I get to the end of it, you're going to be like, whoa, I'm going to rewind that because that was super easy and looked so much better than this. And I'm going to show that to you. It's not actually part of the course, but if there's an easier way, I always like to try to toss that out. There's an option. It doesn't work if, so pretend this was a 2 in front of that x instead of just a plain x. It doesn't work then. So it has to be just like an x and then plus or minus a number. So it does have limitations, but on the problems that it works on, it works really well. So what we do for synthetic is we take, if x plus 5 is like the factor, we're thinking of the 0, and so it'd be a negative 5 is what we'd want to use right here. And it's just, what it's going to let us do is add instead of subtract in a second. So we do negative 5, and then we make this kind of weird box, and then we just grab the coefficients off of this, so we don't write down the x's. So this is 1x squared, so this is a 1, 15x, so that's 15, and then 50. And I know this is looking crazy, but it ends up really good. So the first thing you do is you bring down the 1, and that's because whatever is here is what you're going to make it match. And then we go negative 5 times 1 makes negative 5. And then we add instead of subtract. So if I think 15 plus negative 5, it's the same thing as 15 minus 5. But basically the math looks like what it should look like. And we get 10. And then I just go again. Negative 5 times 10 goes in the next box. So that's negative 50. 50 plus negative 50, 0. So if I go x into x squared, it's always going to be 1 degree less, 1 less on the exponent. So this is going to be an x, since I start with an x squared, plus 10, and remainder 0. So same answer, 3 different ways. This is great. And I'll do this for each of the examples where it's appropriate. If you pick it up, that's cool. You're welcome to use it on my exam. If you have a different teacher, they may not like that. But for my exam, I usually do put one that you could use synthetic or this. So know both methods, because you do need this sometimes. But this is so much more compact and easy than writing all that stuff out. Okay, so for my class, this is pretty much what the test question would look like for this section. Or at least one of them. So we got 3x cubed plus 6x squared minus x minus 2. So we start with what do we multiply x by to make it 3x cubed? So we'd need 3, and we'd need 2 more x's to bring it up to x cubed. So 3x squared. And this times the 3x squared times x plus 3. So here times the x, we get the 3x cubed we're looking for. And then 3 times 3 will make a 9x squared. And then we subtract, so 6 minus 9, those cancel. And then 6 minus 9 makes negative 3x squared. And then bring down the negative x. And then just go again. So what do I multiply x by to make it exactly negative 3x squared? So I need a negative 3 and 1 more x. So negative 3x times x, negative 3x squared, negative 3 times 3 makes negative 9x. So this is a little complicated looking, but it's correct. I have minus 3 minus a negative 3, so that's really minus 3 plus 3, which cancels. So that's why you want to match the sign and everything. This would go negative x minus negative 9, so that's really negative 1 plus 9, so that would be 8x. And then bring down the 2. And then what do I multiply x by to make it 8x would be 8. So plus 8 right there. 8 times x, 8x. 8 times 3 would give us 24. And then negative 2 minus 24 will be negative 26. So my answer is going to be right up here. It's this, I think I will go right here with it. 3x squared minus 3x plus 8. And then minus, sometimes you'll see it written plus a negative. I'll just write it minus 26 over x plus 3. And so it's just the divisor, or the remainder over the divisor. If I do this by synthetic, that would look like, so I have x plus 3 showing, so I need to use negative 3. And then our coefficients would be 3, 6, that's a negative 1, invisible 1 on the x, minus 2. So we'll go bring down the 3. Negative 3 times 3 makes negative 9. And you can see that's the math that's right here. Makes negative 3, and there we are. Negative 3 times negative 3 makes 9. And then negative 1 plus 9 makes 8. So we're right there. That was this little chunk of math. Basically, we're just not writing down all this stuff that just cancels out. And negative 3 times 8 makes negative 24. And then that makes our negative 26. So there's our 3x squared minus 3x plus 8, remainder 26. Okay, so this one has a little bit of a different thing. It's x to the fourth, which means it's going to be really long. And then it also has where it's missing a term. And so we're going to have to do something about that x squared. And I'll show you what here. Let's see. So we're going to go x plus 2. And then this is going to go x to the fourth plus x to the third. And then for the x squared, I'm going to go plus 0x squared, and then plus x minus 1. And so I'm using kind of a placeholder here, because when I start working on this term, I'm going to pick up square terms, so I'm going to need something to subtract them from. So what do I multiply x by to make it x to the fourth will be x cubed. X cubed times x, x to the fourth, x cubed times 2, 2x cubed. And those cancel. 1 minus 2 makes negative x cubed. And then I bring down that little 0x squared I have. So what do I multiply x by to make negative x cubed? Would be negative x squared. Negative x squared times x. And then negative x squared times 2. And then this is what I was saying. If I didn't have that 0 there, then I'd be bringing the x down. There wouldn't be like terms, and it'd get all kind of wonky. So this is basically just to kind of keep everything neat and orderly. 0 minus negative 2 would be a 2x squared and then a plus x. What do I multiply x by to make 2x squared? 2x. And then that will go 2x times x, 2x squared. 2x times 2 will make a 4. And x minus 4x will make negative 3x, and then bring down the 1. So then here I'd need to use a negative 3. And negative 3 times x, negative 3x, negative 3 times 2, make a negative 6. So that's negative 1 minus negative 6, and negative 1 plus 6 is 5. So then this would be, ran out of room up there, but plus 5 over x plus 2. And then let me show the same problem using synthetic. So we do a negative 2. And then these are all just 1s. So it'll be 1, 1, 0, 1, negative 1. So bring down the 1, negative 2 times 1, negative 2. Adding those, I get negative 1. Negative 2 times negative 1 makes 2. 0 plus 2 is 2. Negative 2 times 2, negative 4. 1 plus negative 4 for negative 3. And then negative 2 times negative 3 for 6. And there's our 5. So again, I was going x into x to the fourth, so this will be an x cubed minus x squared plus 2x minus 3, and then 5 over the divisor. Okay, so then these last four are the ones I would have you guys try in class. Remember that you can rewrite this as three separate fractions. I think I'm not going to just because of the amount of space it'll take on the paper. But so I'll just cancel each one of these kind of individually. So first I'll do the negative 3x squared with the y. So negative and negative is going to make positive, and then 12 divided by 3 will make a 4. I got 4x's up and 2 down, so that's going to leave me x squared. And y cubed up, y down, so that'll be a y squared. In the middle, we'd have 15 divided by negative 3, so that's negative 5. 3 up and 2 down on the x's, so I'll leave an x. 2 up and 1 down on the y, so I'll leave a y. And then negative divided by negative will be positive. 21 over 3 makes 7. X squareds cancel, y's cancel. And so that would be your answer. For this one, depending on the directions, I think it actually does factor, but I'll go ahead and show it as a maybe a magic method factoring problem. Or I can do it by long division, and since this video is mostly about long division, I think I'll do it that way. So we're doing, what do we multiply 3x by to make 6x squared? So that's going to be a 2x, because 2 times 3 gets us 6, and then we needed one more x. So that'll be 6x squared. 2 times negative 2 will make a negative 4x. And then so here we have 7 minus negative 4, and that is, or sorry, minus 7 minus negative 4, so that's going to be a minus 3x, and then bring down the 2. Then what do I multiply 3x by to make negative 3x? So that'll be a negative 1. Negative 1 times negative 3, right there. Negative and negative makes positive 2. You can see they're coming out the same, and so that means it's going to be 0. And that means that this would have factored, and actually these are the factors right here. This times this would make that. Okay, so we're going to do x minus 2 into 3x cubed, 5x squared, 2x minus 1. So I would need a 3x squared to make this into 3x cubed. And then 3 times 2 for negative 6x squared. Minus 5, and that makes a plus 6, that'll be an x squared, and plus 2x. So what do I multiply x by to make x squared would be x. X times x, x squared. X times 2, negative 2x. And then 2 minus negative 2 would make a 4x, and bring down the 1. We multiply x by to make 4x, so 4. And 4x. And that'd be a negative 8. So negative 1 plus 8 would make 7. So 7 over x minus 2. Let me show it as a synthetic just to have done that also. So 3, negative 5, 2, negative 1. So bring down the 3. 2 times 3 is 6. Negative 5 plus 6 makes 1. 2 times 1 makes 2, 2 and 2 makes 4, 2 times 4 makes 8, negative 1 plus 8 makes 7, and that is so much easier. So this, again, we did x into x cubed, so this has to be x squared, and then x plus 4, 7 over x minus 2. So this last one you can do any of the three ways. If you remember your cube factoring formula, which hopefully you do, you can just factor and cancel. I'll show it as long division synthetic, and again, just because that's kind of what we're working on here. Plus this one's missing terms, so I want to show that. So I'm going to go 0x squared, and I don't have a linear term either, so I have to go 0x, and then minus 27. So when I multiply x by to make x cubed would be x squared, and I get x cubed, and then minus 3x squared. And so that cancels, that makes a positive 3x squared. Bring down the 0x. So then I'd need to use a 3x to bring that up. So 3x squared, 3x times 3, negative 9x. And 3 minus 3 is gone. 0 minus negative 9 would make a 9 right here. And then x, and then bring down the 27. So what do I multiply x by? Make 9x will be 9. And 9 times x. And 9 times negative 3. And so you can see how it's going to be 0 since they were the same thing. And if you remember your factoring formula, this times this, right, is x cubed minus 27. So this is what I was saying, that you just had to memorize the formula because you didn't quite have enough math yet to be able to figure that out. So there's the math to figure that out. And then just to do it as a synthetic, this time it's x minus 3, so I want to use positive 3. And same zeros as placeholders, so 0, 0, negative 27. So bring down the 1, 3 times 1 makes 3, 0 plus 3 makes 3. 3 times 3 is 9, 0 plus 9 is 9, and 3 times 9 is 27, and then minus 27 plus 27, 0. So there's that same x squared plus 3x plus 9. Cool, so that wraps up chapter 7.